today. Okay. What are we having today? Demo. Tools. Status. Orchard 1. Something. This PR was merged, and this PR is just ensuring that in the link field we can have the anchor like this. That's what it does. OrchardCore. OrchardCore, so let's say 1029 here. That's it, nothing. I'm trying to do. That's when I played with the events. Okay. Oh yeah, so we get so then 29. So this we saw, check for Elasticsearch before vetting, update MKDocs, fix Elasticsearch null ref exception. Was a potential null ref, which was fixed. So the potential null ref was this, I think. This. Now, before returning that, we check if there is something which is not null and the count is something. So this is fixing a null ref. To attach the dashboard part to content page with DashboardWidget stereotype. This is what we talked about last week. We have a new event handler to be able to customize the content types and content parts and their usage in parts and types. And field to parts, part to type, types to parts. Beautiful. Don't want to look too much because I'm afraid I will see something and I will, you don't see that. That should be fine. Cool. And now the widgets, they will always have the correct part as soon as you say it's a widget. So easier. Do you know if there are any other parts that where we do that actually?
We don't, not that I am know of, but this is actually allows anyone, like in my own project, I have a way to do the same thing where I need a content part plus stereotype. We should be able to follow the same approach to implement the event handler where you can auto inject the content parts. That's the power of this PR. You know, changing to widget, the dashboard widget was just an implementation of that feature. So
so in Orchard 1, I think we have several ones like this. So that's why I'm asking. That's weird that we don't have more. And should we have a reusable way to do that, like a class that can be configured with a stereotype and a part, or an instance of a this handler that you can just say, oh, automatically attach these parts maybe to this stereotype, and then people don't have to write the implementation every time, because this is very common. Right? We have the events, but we have this behavior now that we might want to be able to add everywhere. Or should it be like, so this could be a base class, a base instance to register, or it could be a setting somewhere where we say, oh, this stereotype has this part, but it's a configuration such that we have one event handler that will always check if these stereotypes should be having all these parts, like a component by default, something that can attach parts to stereotype. And it could be by code, and it could be also in the UI. You could say, oh, let me describe stereotypes and their mandatory bounds. It could even be confused. Just opening discussion for the future. Maybe people have ideas. Good. Fixed namespace. Space and location. Update, template, content validation. Template controller, object templates. What do we have? Validate. Okay, so someone creates a template empty, and so we just catch it and say, we don't want to do that. You want to change the placement and say, hide it, none placement. This is not modules. Is it a module? This is not a module. Is this a module? This is not a module.
I actually think we do have a module called placeholder.
Placement, you mean?
Or placements, yeah.
So
Yeah.
is this a module? Because that's clear from templates. Looks like a module. It's a module because just one up. So this is not. This is not correct.
Yeah, it's not good. Adding a module to another module reference.
Remember the details, but there are some reasons that we don't do that. Or also it shows something that you shouldn't do. So where is the dependency here? Or just to be able to access the controller? Nah. Just can use a name of, can use a route name, or we can use it right here because here we are generating a link to something that might not even be there. Or if it has to be there, then let's make it a dependency, but we don't want that. So that's a here in 16944. Okay. Sure. Okay, cool. And that's it. What else? PRs, topics?
We can talk about the, well, this one you might want to talk about, but we can also talk about the time zone. See if you have any.
Oh, I forgot about the time zone. Yeah.
Of course you did.
Oh,
You're too busy with the elections, the US elections.
I can't vote. I'm French. Okay, time zone. So context. Let's go back to the first issue first, right? Because that matters. Let's take a file. Let's take this file. This PR that points to this issue. So, some time ago, someone saying user time zone service needs an interface because they want to mock it. Because they have some tests and they want to be able to change what the user time zone is for user in their test. And at that point, we just had this service as a class, registered as a class, and you could use that if you wanted, but it was more for internally to provide a time zone of a user. Well, what was the single PR? So you should see that an I time zone selector useful to change. So we have an I time zone selector and we have a user time zone service that probably implements that and returns the time zone for a user. So let's go back to the PR. And the PR said, in the PR, we said that, okay, the user time zone service was not actually doing user time zone service. It was doing some cache at the time. So it had get user time zone async, update user time zone async, get current user time zone ID async. It was doing that, so it was a service that was getting the current user time zone. Okay, you could update time zone, and if you had an I user, it would just invalidate the cache. So it was just like an event. And this one was to get the time zone IDs, which is probably used here. Get user time zone. We convert the time zone ID into an actual I time zone object. That was what the service was doing. And that's it. And we had the user time zone selector implemented I time zone selector that was using this service to provide the time zone for the current user. So it would just resolve all time zone service and say get user time zone, the time zone ID. Kind of sad because we actually have a get user time zone ID. So that's not really anxious that directly, but that's what's the case. Change in this PR was to say, let's make this user time zone service an actual thing better than what it is and implement user time zone service. So the change here, the big change that we realized last time was that get async is, well, now the service is get async, update async, and that's it. Okay, so get the time zone for user and update for user. And the result is the I time zone. But the big change here is that it's using an I user for the both of them. And before it was saying get the current user, and it had a get user get current user. So it was just doing get current user all the time. And then you could just say update to invalidate the cache. So it was not really update. Now what it's doing is the get async is asking for user, getting a time, calling the internal method here. So that's fine, and then converting the ID to a time zone. And now the update is still removing the cache entry. Okay, so that's the same thing. But the get async is calling the get time zone ID async. user, it's looking for the username. I'm confused because at some point I thought there was or it changed after that. Well, let's see. No, it's another class. Okay. Well, so it's taking a user, taking the username, getting from the cache and returning the value. But the big change is that now the user time zone selector, because the service is not bound to the ambient user, but to any user, now the user time zone selector has to load the current user from its identity, which means it will do a database query to get the iUser object to in the end get the username, which we already have. But the interface taking an iUser means that we need to get a user from database. And so calling get timezone async from the timezone selector from the service, the cache will be useless because we are caching a value, but before hitting the cache, we are doing a database query to get the user. Okay? So that's something that Dean said after that, say, well, now it's good, we have a service, but the cache is useless because it's caching something, but before hitting the cache, we are doing another database access. So last week, during the triage, I think, or in the meeting, we talked about a potential solution. We said in the issue that let's not change the iUser interface, but let's move the cache into the user timezone selector such that before asking for an iUser, we can return the cached value from the user identity here. So Mike did a PR. Probably this one. So I don't know why you deviated from what we said, but at the same time, yeah, I trusted you that you had reasons because you were there in the meeting. And when you start implementing, you see some limitations.
So the reason why is after I looked at the implementation, when I actually looked at the code, there is a method called update async. And it doesn't really update anything. It just clears cache. So like having it called update it's bad API because it doesn't update anything. So when you say update with iUser, to me, without looking at the implementation, I'm like, okay, it should be updating the user, but it doesn't really do that. So I think the update method is just useless in this case. And I think it's okay to have a service that caches and manages the cache. But I think all we need here is one method that's called get async. And that one gets a time zone, either from the user or from the cache. That's exactly what I did here. Instead of passing iUser, I pass a username. And that username, we're able to cache or check the cache. And then if we need to, then we'll create a database. But we don't create a database unless we know we have to. At the same time, I use the event handlers, the user events, say whenever this user is updated, we're going to clear the cache. So there is no need to say remove the cache manually from the driver as well.
So when I saw that, I was like, what did I see? Yeah, I felt like we were deviating, like the initial issue we're trying to solve, like with starting a path to make a service that was reusable, but now the service we thought we were making was a lie, and we are still digging even more there. So I'm wondering if...
Yeah, but right now it's actually useful because now you have a service that is responsible of retrieving only the user time zone, either from cache or fetching from database. So that's a responsibility. Now that service is used by the selector, or it could be used by anything else.
Okay, so today it's used just by the selector. I'm about
Correct.
to say, why do we need this service if it's just used by the selector?
Yeah, and that's what I'm saying. So this is useful because what if you want to use it? Because it is useful a service to be able to retrieve the time zone of a specific user, right?
So
So I
if we don't
think it would
have
be
this
useful.
service, if we don't have this service, you see, like now we are mocking the thing. We had an interface to be able to mock something that is just providing caching. I'm like, why don't we have just then the I time zone selector? They can mock it, and then there would be no caching, but the user time zone selector could provide a cache by itself. If we are creating a service,
yeah, we
just
can
to be able to
remove
provide
that service and put it in the selector if that's what you're asking. But I mean, it just won't make it as useful.
But useful is what? Is caching? Do we have to
Well,
create?
it does more than caching.
Okay, what?
It provides you the time zone for that user, whether it is from the cache or whether is it from the database. So you give it a username, it's going to give you the time zone for that user.
By doing, let me say, by doing as user time zone, the time zone might be. So there is really not much logic, right?
Well, it's that, and then look at line 71, that it actually fetches that user from the database if needed. And also if the user does not have a time zone, so they don't have, it's blank, they haven't selected anything, we also cache it to prevent it from being called yet one more time on every single request. So there's double steps here that it actually prevents the calling the user multiple times.
Time zone selector itself. So the goal of this time zone selector is for the current request to find the source of the time zone. We have different implementations. There is the default from the site. There is the one from the user. This could be another one. And the idea of these selectors is to say, use this time zone. That's the best one. And we have a priority. So I agree that it's not its job to manage the time zone of a user, where it's stored and everything. At the same time, a user time zone selector is an implementation to be able to find and return the time zone of a user. So to just be a get. And this is what the service is providing. It's just providing a get and invalidating of the value that is cached by this exact service, not anything else. It's just invalidating this service state. So there is service method to invalidate this service state. So just loading the time zone from user, I don't know, like if it was there would be just one method, get time zone async. And then because it's a user time zone selector, it would load. If it's not in cache, it would load the value, the user, pick up its value and return it. If we didn't have this service, the user time zone service, people would have to load the iUser and do the as user time zone. Yeah, and I'm sure we do that somewhere else, no? I would have to. display driver. Okay, so the display
And that's
driver.
no longer needed. That's why it's removed now. Because we don't need to explicitly remove the cache. We're able to listen to the event when the user is updated and just remove it automatically.
Let's look at the driver. This is the new PR. Okay. So the new PR, I say you removed it now. So this driver, this is to be able to change your own time zone, right?
Correct. Yes. To update the user's time zone, whichever user it is, or it could be yourself. Yes. And so you see how before we use the update time zone to update the user, meaning to remove their cache. We no longer need to do that from the driver because it's easier, or even better, do it using an event handler where we just know the user is updated.
So what is invoking this event handler?
Say that again?
What is invoking that handler?
Look at the update user time zone service. It actually does two things now. Look at the user time zone service, not the base class. This is a pre-existing base class. Yeah, you see how I'm inheriting from that class now. So this service is a listener and also a provider at the same time.
But so the driver is not running it?
The driver, no, because once you update a user and the user is updated, we trigger events.
Sorry. I didn't realize that you were taking like the user's event, like any kind of event of the user. So if the user changed, then you're like, okay, let's invalidate that because the user changed. Okay, so
correct.
That's good. And I would just have so from what I see and what you tell me, I'm even more convinced that we don't need that thing because you even removed it from the driver, meaning we don't even need it from the driver. So now there is one less thing that is using it, which was the only thing to use it with the thing where what I think should be it, which is the time zone selector. So the time zone selector could also implement
are you saying to, instead of having the service, just move everything to the selector? Am I understanding you correct?
Yeah.
Okay. Yes, that is definitely an approach. The only disadvantage with that approach is it's not as reusable. Having it in its own service will allow it to reuse it in other services beside the selector. Right? Time zone is a common thing that you might want during in your project. And so having it in the selector, now you're tightly coupling that logic in the selector. And if you need a service that tells you what's Sebastian's time zone, then you're going to have to create your own because there's no other way around it.
So why then isn't even the driver using this service, which is so useful?
Well, before, I guess it needs it to be able to clear the cache anytime that.
Before,
yeah, but in this case,
it's useless now. Even in this case.
Yeah, but we still do it. The logic's still there, though, right? We still invalidate the cache using after the user is updated. We still invalidate the cache,
but not using the service. That's what I'm saying. This service is useless because we don't use the service. Meaning, by definition, it's not used.
We don't use it. We don't use it. But it doesn't mean someone else isn't going to be using it.
But what I'm saying is that if they want to use to get the time zone, even our driver doesn't need this service. So do the same as a driver. Just get the user, get its time zone. Don't ask a service to give you a property of something. Because
no, the time, so our service still is invalidating the cache. So that the caching portion is completely contained in that time zone service. So it's doing its own caching, it's doing its own invalidation when it knows it needs to be invalidated. And then that logic is exposed under one method.
So we create a service just to provide caching. So it
to provide a time zone, which could be cached, maybe not. It depends on if it's cached or if it's not.
Well, it's providing caching then. That it's the default of a cache, like it's caching. If it's returning a fresh value, it's still part of the caching logic. So this service is only providing, it's only adding the value of a cache. That's the only thing that is adding. And yeah. So should we have a? I'm mean, but should we add a service for all the properties of the thing because they could be cached and that can be useful?
I mean, you know the answer to that, but in this case, they're using that time zone, and time zone selector is called on every single request.
That's why the selector should cache it, because it will be called in every single request and it caches its result. That's what we do in most of the services. When the service is used a lot, a component is used a lot and accesses the same value multiple times a request or every request, it caches the thing. And then it tries to get a way to invalidate it. So I'm sure we'll find a lot of examples in Orchard where we do local caches and then we don't ask someone else to cache it for us and call the service and assume it will be cached. Just creating a service just for caching, because this is what it's doing. And then, yeah, that's good.
Yeah, I mean, I get your point, right? But this isn't adding a new service. This is enhancing an existing service.
No, but
and keeping it reusable. So that's the key. Is if we want to move this into the selector, which we can absolutely, it's just one less service that people can use to execute that logic.
Yeah, but again, one less service. Everything we can remove is better because less things that can break, interfaces to change, cache invalidation because we have to ensure the cache works for everyone and can be validated for everyone. So it's, yeah, and the proof is that, oh, we just added a service to fix an issue. And then now we are trying to fix the thing we added. Maybe you should have said, oh, let's remove it because people can't mock it and it's completely broken. And the only interface we have is the I time zone selector. This could have been mocked, but it was in the issue, right? I said, why don't you mock I time zone service? And they said, because it's not sufficient, because we can't access the service that does the thing. So that's my concern. And the driver was using that also, and now it's not even using it. So yeah. Obsolete. Now we have a new thing. Yeah, so this is more clever than just invoking a method called or update or invalidate cache. So that there is a way. There is another way also that is not commonly used, but that was made for that. This is called iSignals. I don't think you're familiar with that, so you tell me.
What is it called?
iSignal. So let me show you.
No,
it's like an event handler, but plus. You see abstractions caching at iSignal. So, and there is a distributed signal also, message plus. So this thing will have a get token, iChange token. And the idea is that you say, give me a token representing this key. and you get a change token. And you can also say signal that the thing has changed. And this way, anyone can say, so in the case of the time zone for the user, you could say, when you cache something, you can say, oh, I will cache the user dash time zone. So this is the value that. So when you read something that is the user time zone, you will ask for a token representing that. And when you change something, then you can say anyone who use the value user time zone, they need to know that the value is no more valid. So the next time the user, the component is using the cached value, they will check the token that they saved and say, is the token still valid? And this stuff here will actually invalidate your token. So you know, oh, the thing I have is invalidated, so I can just ignore it. And this change token is also what is used by the memory cache. So when you add an entry to the memory cache, you can add a token like this, such that you can signal from any other component that this entry should be removed because you depend on that to be valid. So this can also be used to have an entry to be removed from the memory cache, even though it's not the entry that you get, but it's something dependent as change, so you want to remove it. Example, if you cache the user time zone in the memory cache, and the user changed, you could ask for a token for the specific user and put it in the entry with your user time zone, such that if anything in the user changed, then this token will change and it will invalidate the entry. So this is high signal. And I believe that this thing is the one for the distributed one. So this is different. So this is used probably in the dynamic cache, and this is why we did that. So it's like event handler, but not constrained to a service that you have to implement with predefined events.
Yeah, that's definitely helpful. I have to see how it's invoked, but it's definitely useful.
Yeah. And the service is super simple, right? It's like, give me a token. And so I depend on that. I want to know when this thing changes. And then this one says, oh, I changed this thing. So the only contract is the keys that you will use to describe something.
So the key would be the cache key.
Yeah, probably.
But then the cache is still cached by the caching service.
In our case, it's different because we use the distributed cache. That's different. But if you have something in memory this way, it's even better with the memory cache because the memory cache supports that. So when you have something in memory cache, you can say it depends on this token. So if anything changes from this token, if the resource behind this token changes, remove the entry from the cache. So the next time someone will try to look it up, it doesn't have to know that something has changed. The entry is not there anymore. It has been removed from memory cache, so it will just fetch a new one. Try to look where it's used. You'll probably have some good examples there. It was also in Orchard one, but done differently. Also, the nice thing with memory cache is that you can have multiple tokens. So you can depend on many things. That's why the dynamic cache is unique, because when you render a shape, you will depend on the user that rendered it, on the content items that were inside. So you can say, oh, this shape needs to be invalidated anytime that or that or that or that change. That's why it's important. Okay, well, so the PR itself, I gave my feedback. If you find an approver, then you can merge it.
I don't think anyone cares. So it's either we should decide to move everything.
Ask Dean. They will give you feedback. We should send the recording to Dean. Dean, watch the recording and tell what you think is better. Because You don't care, I'm sure, Mike. It works for you, but Dean,
Yeah, I don't care. I mean, I see the problem. It's not that it's working. I mean, it is working quite expensively. So it just has to be corrected, whether it is that we moved everything to the selector or we keep everything into its own service.
we can ask. If it doesn't care, then you win. You did the work. I send a PR to him, then we'll see if somebody cares. Okay, so that we said other PRs. Yeah, there is this one that's interesting. Ishan is already fixing what he said. This one also interesting because we took some time on. Oh, let's look at this one actually, right? Because that's a nicer story than the recyclable. We'll see what we have. So this issue on Thursday we triage, and there were 2 new people showing up. Like, are you lost? It's usually Antoine and Dave will join Mike, myself, and George. So there was Annie, and who was the other person? I don't remember the name. So what they came up with is a bug when you create a content draft saved event. And they want to publish the content automatically just to see if it's working. It will not publish the content. It will just keep. And then if we try the workflow instance, it will just work. So we debugged it, and what we saw is that there was this code that was run before. So it was saying if the inline event content item ID is the current content item ID, then don't do anything. And this was the case, like, oh yes, we are running in an inline code, meaning in the same request as the content was saved as draft, this event was triggered by a content handler, and this is when we say this is an inline event. In the same request, the handler triggered this workflow. And we say if it's the same content item ID that we're currently saving, then don't publish it. And I think, as I'm saying that now, that why is that is because usually the draft event is coming before the publish. So we are like, well, we don't need to publish it because it will be published after. But not in this case, because we really wanted to create a draft. So, and actually that kind of makes sense now, because this task is saying, if you are creating a workflow that publish something when it's a draft, you are stupid. You are doing something very weird. Why didn't you just publish it? Like, if you created a draft, it's not because you wanted it to be published, right? So I don't know. Maybe that was the reason of this code, but at least this thing is, well, maybe it was just to help people, but it doesn't help. So I think we could remove that. And I said, with this code, it works. It's just saying, if the content is not a draft, then there is nothing to do, because it's an this is a documented outcome. No, nothing is done or published. Yes, we published it. So it says, if it's not a draft, then we don't do anything. We don't try to judge you by saying, do you really want to publish something that you just created as a draft? That's weird. No, that might be reasons like validation, for instance. So that was a suggestion. And we asked Annie and I don't remember the name to test it. And Isham, in the meantime, implemented the suggestion because he didn't know about the context. I commented on the PR, we have the PR. And then I reported that it works, that we tested. And we also asked for more tests, like publish on a schedule. So when it's not in line, so does it mean that there was another bug? At least it didn't work in this case. The publish content on a schedule workflow. Another change may be given to decide the new content items so the content item makes me publish content task. Publish content task. The content item was not found. Interesting. maybe this is a different issue, I believe. This is a different issue, maybe another problem. Fix, and this is a PR formation. What is the PR formation? This one. So we'll see. But otherwise, the code, to me, looks good. It has been validated that it's working, but there is another problem with another task. Oh, no, there is, oh, wait. No, there is not another problem with another task. Apparently, it's the same task, so you need to wait for feedback or add more tests for that. To look for that. Okay, so we look at it on Thursday, but we need to resolve the other issue. Maybe this was working before. I don't know. It's still a very issue. We'll do that. It's like nobody has ever used the publish task here, which is weird. That comments, anything to add on this one?
No, you might want to talk about the recyclable memory stream. I don't even know. There's a whole lot of value here.
I don't think so. There might be somewhere you can use it, but not here. So where is the thing I just told you? An issue. Okay. Adam said use Microsoft IO RecyclableMemoryStream. Describing the code. New memory stream could be optimized with pooling using it. So we stream and use the pooling RecyclableMemoryStream, and then create the PR. So this is the PR. PR here. This is a new package, okay? And then instead of new memory stream factory.elasticsearch. So it looked like, yeah, that can just be better. So what I saw here first is that this, so memory stream factory is a thing that you created to have a singleton, okay? To have a singleton recyclable memory stream manager, and then you can do get stream. Oh, you updated the PR in the meantime, okay? Because no, right? There were multiple of them, right? Before.
Yeah, there was multiple, yeah.
Okay, but I get feedback, and that's why I see it somewhere. So when you do get stream, there is one that takes some size. Tag is just an internal tag for telemetry, and you can also provide a size to say what is the initial size of the stream you want to get. And what is important is every stream that you get from this thing here has to be disposed, because if you don't dispose it, you don't return the memory that you are getting from with this stream. You don't return it, and if you don't return it, then what's the point of pooling? So everything has to be disposed. So here, what I saw is that you used it in many places, unless you removed it everywhere I said remove it. But here, no, in this case. So the code before using var equals new memory stream of data. Data here is a byte array that is provided by some source. It says deserialized, default document serializer. So we have a byte array, and we say memory stream, and we say deserialize, because the deserialize here takes a string. When we have a byte source, it asks for a string to be able to read byte by byte or a few bytes at a time. So it asks for a string. So we create a new memory stream. And what happens here is that when we do that, the internal array of the memory stream is set using the data that we pass. So there is no allocation at all. It's just a new object that wraps a byte array to provide helper methods to read the byte array. Okay? And then when we are done, we say using dispose, it will do nothing. It will just lose the reference to the byte array. There is nothing to release. And that's important, because if we do new memory stream without the data, it will create an array. And not only will it create an array, but it will increase the size of the array every time we try to write to the stream. So source. And
on this specific line, I think the user stream can be dropped, because I think the serializer accepts a byte array directly.
Yes, and that also matters, and that can be useful sometimes. But in this case, it's not, you will see. So here
in this case, it's not useful.
So memory stream, you can give a capacity. So if we create a standard memory stream with a capacity, it will create a new byte array of this capacity. Okay. So the idea is that, oh, I want some memory. I want to be able to write to it and to read it in an easy way, like with read something or write something. And I want it to be like 1K by default. Okay, good. But if we provide the byte array, it will take this byte array as is. Okay. And what's happening is that at some point we'll write to it. Here. And validate the arguments. And it checks the capacity. And if it tries to write somewhere above the capacity, it will say allocating new array equals ensure capacity with the new size. It will actually create a new array, copy the old data from the old buffer into the new bigger array, and keep the new array. So the issue with keep about there. The issue with the memory stream, the standard one, is that if you use it to add data, it will allocate every time it will go over the size of the current buffer. So it will allocate the first buffer and then allocate again and allocate again. So it's just allocating a lot. The advantage of, oh, you removed it. Okay, the advantage of the memory stream.getString is that the array that it will use initially will be one from a pool. So it's something that was available for us to use. And when it grows, it will say, and this is very important with this implementation, the recyclable memory stream here. When it grows, some pools, some stream factories could say, oh, let me get the pooled one, which is bigger than the one I had. And it will get another bigger one that was already in the pool, or create a new one, right? But this one here from this package is more clever, because it will say, I will keep the one I have today, the one with 1K. And if I need to add more, I will get another one, a second one, and I will create a row of arrays. It will create a list of arrays that it's getting from the pool. Okay, so it's not trying to get a bigger one and copy the old memory to the new one. It's just getting yet another one to add to the previous one. So there will be two arrays. Let me show you. So we have like 1, 2, 3, and then let's say, oh, we need to add more data. Oh, the array is full. So we need, instead of creating a new one and then put 3, 4, 5, 6, 5, 6, okay. This is what a pooled array will do usually. No, this implementation here will do, let's keep this one, and let's get a new one with 3 entries, for instance. It depends on what you want to add. 3, 4, 5, 6. Now we have 2 arrays. And if we go over the size of the array, it will say, oh, let me get another one. Okay, 7, 8, 9. That's what it does. So it creates a lot of arrays internally that are pulled from a pool, like the array pool, shared, whatever. So that's what it does. It's not just growing an array that is pooled, it's pulling a lot of arrays. And when we dispose the stream, it will return the 3 arrays back to the pool. These arrays can be small, can be big, can be medium, whatever. It's just the pool that has to decide that. Okay, so that's why this thing is useful. In our case here, this case here, before you had, I believe, getString, it's not necessary because we are not writing to this buffer. We are just reading from it. There is never an allocation. So in this case, it's useless. So there is nothing to do. The code we have here can't be better than that. Okay? In this case here, it has to be better. Because in this case, we say, let's create a new memory stream. So first, we don't say anything. So it will create a new array with a default size. And then it's actually an array to move this data, which is an array, to another new memory buffer. So we actually are trying to compress some bytes to some other byte array. So in this case, this new gzip stream will try to read that one and write on that one with the compressed data. So this will allocate. So this is very useful because now, instead of allocating first a 1K array, and then maybe the zip file will be, I don't know, 100K. So maybe it will say, okay, 1K. And then when it reaches 1K, it will say, oh, now I need a 2K buffer. And then you say, now I need a 4K buffer. Now I need an 8K buffer, and so on and so forth. So by the time we reach 100K, it will allocate like maybe 10 times, okay, 8 times, let's say. And then, so we allocated 8 different arrays and 7 of them for nothing. And it's still 7 allocations for nothing. Even the 8th one is still for nothing, but it's a big one. With that stream, what we get is, oh, the first K, it's for free, it's pulled. And then the second buffer, maybe it will be, so maybe this one will be 1K. Maybe this one will be also 1K. I don't know how it will handle that. Maybe it will be 4K, okay? And then and so on and so forth until we have as much memory as we need to fit the whole zip file. And when we are done and we call dispose, because there is a using here, all these arrays that were either new or taken from the pool are returned to the pool automatically for the next zip file or the next usage of this get stream to be used. So that's why here it's better, because in this case, the worst case is the same as before, but better, because we might probably just get a few of the buffers from the pool. But here we got nothing from the pool. So we were just allocating new memory all the time instead of trying to reuse it. So that's one reason that here it makes sense. Okay. So whenever you see something with an existing data set that is not written to, you don't need this one. Now there is a scenario you mentioned, Mike, which is you can also do something data. And that matters if we want to start with a buffer, but add something to the buffer. So this can be the first set of data, but if we want to add more data, if I was doing new memory stream data, you can do that. You can do after that, you can do ms.write, and it will create a new buffer, copy data to the new buffer, and then write what you want. With this one, it initializes the buffer with your data, fine, but then the next one it will create is from the pool. So the first one will be your data, and the second one will be from the pool. Okay, so that's still better to do that here. If we want to create a stream from existing data because we want to add more things, that still makes sense in this case. So here, gzip string. So here, no, we are just probably decompressing. So this is creating the first one, so this doesn't need, but the destination one, so this one is to read, and this one is to create. So we need that. So this in this case is better. Okay. So what I'm seeing here is good. So but I commented before on the PR, so you understood the changes to make. Memory stream, file stream, copy to memory stream makes sense. We are adding data to this stream. Oh, and very important also. So that is wrong. That code is wrong. But well, it's wrong. Maybe it's the best that we can do. But this is very important. So once you have, nobody is talking, so I'm just doing my monologue. It's fine. Please interrupt me if you have questions or whatever makes sense or doesn't make sense. So once we have this memory stream here, so we got this thing, getting from the pool. So we add data. Okay, so here we do get stream, file stream, copy to memory stream. So copy to will add more data to this stream, so we'll have some arrays. Okay, like this, some blocks. Let's call them blocks. And now it's done. So we have written all the things we wanted to this stream. So there are internally like 8 blocks. What we want to do usually is to use this data to make something. So here in this case, it's saying I want to convert all the bytes to base 64. And here we are doing, so in memory stream, what we do, there is no choice. We do memory stream.toArray. Okay, the toArray will return a reference to the last buffer that it used, so the biggest one that it still had. Okay, that's what it's doing. So this thing usually doesn't allocate. I believe it doesn't allocate. It's just saying Oh, it does allocate actually. Yes, I'm stupid because I've always known that it was allocating, but I thought it could not allocate. It is actually allocating. You see, it's saying, let's give me a new. Yes, yes, I'm stupid. So let me explain why. So if we use the standard memory stream and we add some data, okay, what happens is that we have a byte array, let's say, of 64K. Okay, but we actually just wrote like write 50K of data. So we write 50K of data, and because the buffer before was not 50K, it increased to 64K, like a multiple of 2, power of 2. So 54K. So we still have 14K to write, but that's all we want to write is 50K. So at that point, we're like, okay, give me the 50K. So we call toArray. And what you expect, what you get is what you expect, which is a byte array of 50K, okay? Just the 50Ks that you wrote, not less, not more. Give me an array of the 50K I wrote. This is what I wrote. But internally, it had a byte array of 64K. So it can't return this one. It has to return you a new array of the actual correct size of the amount that you actually wrote. So that's why it has to do, give me an allocated initialized array, like, so it gives you an array which is completely empty, and it called, no, uninitialized, meaning I don't care if it's zeroed. It can have random value inside, even secrets, because we will copy everything from the original buffer to the new one. We will erase every byte of this array. Okay, so it cannot be initialized. It's faster like that. So that's why it's doing that. That's why the toArray will always allocate here. So when we do memory stream the toArray, we allocated something to create, and now we are reallocating to get the perfect array with the perfect size. Okay, memory stream. But wait.
So I think that buffer, we need to get a limit.
So there are two things here. So this what I explained was what was happening here, okay, in the previous code. But now you're actually still doing it, even though there is a better way to do that. So let me show you. So when you do try get buffer, so in this specific package, the try get buffer, this is specific to this memory stream, okay, not the standard one, but the recyclable whatever memory stream. The try get buffer, if you look at the doc, well, I've used it before, there is a get buffer and a try get buffer. This will either give you, no, this will give you a new array. Also, this will actually, so the try get buffer will do that. It will take all the blocks and create one new one, okay, 50K block, and copy each of them at the correct position of the 50K, okay? And it will give you that. Pretty sure that's what it does. And if you look at the, but it does it better than a toArray, apparently. But try get buffer, that's what it will do. And that's the fine thing, is this is what you want. But there is another thing that is better, which is a read-only sequence. A read-only sequence of bytes is like the read-only span of the bytes, but it's a sequence of them. It's an array of things that are a list of bytes. So you can get a read-only sequence of bytes if you just want to read something. That's why it's done this way. And it will give you a new object that contains pointers to all these blocks. Okay? And the data behind that, and just the last bytes of the last block that are necessary to get 50K exactly. So when you do that, it doesn't have to allocate anything. In memory stream, there is a toArray. You need a single array. So it had to allocate. But with this new API, you can say, give me something that will iterate over all the buffers, such that I don't need to know that it's one or n arrays. I just want something I can read the bytes from. And this way, by doing the dot, what is that? Not return memory. So what is the thing? For each, you can do for each. So this is, you can do a for each. Now I remember. If you do a for each on the stream, you will get a read-only sequence. So there is a for each, but there is also something else. There is a get span. That's not what. No, that's not that. This is just to write. This is IDEFER. Yes, stream.get read-only. Okay, that's the get read-only sequence actually. So you do a get read-only sequence, and you have memory, and you can do dot span. And but the only problem with that, the get read-only sequence, it's not allocating at all. But you need an API that accepts that can take that. So if you have some things that can get byte by byte, that's fine. If you have something that takes a span, that's fine. I'm not sure that the 2 base 64 string takes a span. But at the same time, I'm like pretty sure it does. So let's see. Why would they not do that?
Good, yeah. I mean, that's the way to save allocations. Yeah, right there, it takes it. Fine.
Here,
340.
there is the try to base 64 chance bytes. No, this is converting to another set of bytes. You want a string. So
no, I've seen it up top. I've seen
it?
I thought I just did go 23 here. Line 20.
This one.
Base 64.
This one.
Yeah.
I got it.
Yeah,
so there
is
one
there
that takes that. So you
yeah.
So you can do that. And now in this case, so that's important because in this case, you can't imagine how many allocations we had there. Because we had
that's the one that I'm using.
The 2 array, and then
that takes the
no,
so before the one that's 2 buffer, that accept buffer. One actually
yes, but get buffer is allocating. I believe it is allocating a new array try get buffer. That's why you need to do get read only sequence and then pass it there.
There is no get read only sequence. Nothing. Let's see. Yeah, I don't see it.
It's there, it's documented, and I've used that. So not on MemoryStream, on this thing that this library gives you, which is a recyclable MemoryStream. This is different.
Yeah, wait. So that's a stream. That's so that's a memory stream, and then
no. Well, be careful. Not the method on the base class MemoryStream, on the subclass RecyclableMemoryStream, which is the one you should have here. But getStream should return. Maybe that's that's the issue you have.
Yeah, so I think we have to cast it.
Yes, you need to return
like
a recyclable. Yeah, you try to hide it, don't hide it. You have to return a recyclable MemoryStream in this case. The same way we use this string for the Z string builder, right? We'll see, but just saying that's the way you should do that. There is no thing on the base class that provides it. And in this way, there won't be allocation. So here it explains why the get buffer might be fine. The get buffer returns apparently, is it written in a span? Might return a span, that's why you said, right, that you got a read-only span. And it would do that if internally it only allocated a single array. If it had multiple blocks, it can't give you a single span. That's why it's called try get buffer. And in this case, you say, okay, then give me the list of blocks. But if, yeah, that's the only thing that. So yeah, so now you understand everything about this thing. So yeah, there are many ways. There are probably some ways where we can get an advantage of that. In this case, we can't. Because we need the string to that. There are maybe other things to improve, right? Like when I see, I don't know. To look into that. At least, yeah. This thing here.
So wait. I'm looking at that right now. So it's giving you a read-only sequence bytes. We able to convert that to a read-only span? Let me see.
It is the read-only span.
No, it's not.
It's not?
No. Read-only sequence is
not. You can only do a for each on that? And then you can't pass that to a base 64 string? Kind of sad.
Correct, because it's, unless we're able to, right? Yeah. So it's like taking it, go looping over it and then creating a read-only first, last. You know, that try get buffer, I don't think it allocates.
Mm-hmm.
It does not allocate, I don't think.
Yes, it does. If get buffer, it tells you in the documentation. If you have
it's a greater than.
If you have a single block, and that you don't know, if you have a single block, it will return you the block, the slice of the block that you use. And that's fine. That's why it's called try get. If you have multiple blocks, it can't. It has to return you a read-only sequence, like a set of blocks. And it can't be a span anymore. That's why it does that. And the documentation states it. If possible, a reference to a single block will be returned. If multiple blocks are used, they will be converted into a single large pool buffer. You see, it will.
Yeah.
So, yes.
Yeah, I'm looking at it. It actually does. It will. You know, I'm looking at the code.
It will not allocate. Actually, it will return you another pooled. So it will copy, which is better than what we did. So get buffer is better than nothing actually. But don't call toArray. That for sure. So in the PR, if you can't do a try get buffer, do a get buffer. So just do get buffer, don't do try get buffer, just do get buffer. If you have to do toArray at the end, remove the toArray and do get buffer instead.
I don't think we can use that get read only sequence.
Yeah, then you do get buffer. That's fine.
Yeah.
That bug. Oh, there is nothing. No. We can just, yeah, and we can access all the segments, but the base64 thing doesn't accept that, so that's useless. Okay, but get buffer in this case, that is better because it will get a pooled big array instead of creating a new one. Awesome. Okay.
It's strange why they don't give you a read-only stream. I mean, read-only byte array.
Again, you mean the recyclable stream?
Yeah.
Because they can't. A read-only span, the ROS. That's why they call it after my name. That's why. So the read-only span.
Oh, because it's one. It's reading. It has to combine multiple.
It's a contiguous memory zone. Okay, it has to be contiguous. Contiguous. Yeah. A block is contiguous. Two blocks is not contiguous. This one could be at the beginning of my RAM and this one at the end of my RAM. Okay, there is space here in memory. I have two arrays, but they are different in memory. So you can only get a read-only span from one block. If all your memory in the recyclable memory stream was in one block, by chance, maybe it was a 2 megabyte block. Okay, even if you just wrote 2 bytes, maybe it's a 2 megabyte block, then that's fine. It can return a read-only span, a slice of this block. Yeah. But if it's 2 blocks, it can't. That's why it says, then give me the read-only sequence. Give me all the blocks. I will be able to use that. If you can't use that, then you do get buffer and you say, okay, then I already need a block. So please give me one block and copy all the micro blocks into the new one block. But the new one block, it's a pool block. It's not a new block. So it's still better.
Well, I updated it anyway.
Think about it and we can talk about it next week or Thursday. But that's very important. Cool. Thanks, everyone. Slate.
Thank you.
Bye. See you later.
Hey guys.
Thank you. Cheers.
Bye-bye.